What I'm talking about is an alternative to DRBD. Is anyone here who doesn't know DRBD? Okay, you know what it is. It's replication on the block layer level. That means file system, etc., are above it and are not under consideration here. So the most important point is the difference between DRBD and Mars. The interface is very similar, but under the hood, the technology is very different. So I will show it to you how it operates, what's the main idea behind Mars, and I'll talk about a little bit about performance if you have time. Okay, this picture here, can you imagine what it means to replicate to a planet Mars? Okay, the current implementation of the software, Mars will not do it because the TCP protocol will not work over this distance, or such a distance, but the basic architecture, the principle of Mars is designed to do that. So this is kind of specifications. You probably know that DRBD is a kind of RAID 1 over network, and that means the distance is limited. In practice, I think the limit is about 50 kilometers, and the latency, the network latency, will be lead to performance problems if you try to exceed it, or if you have the problem of linking multiple data centers to each other, and you have some network bottleneck in between. So you run into problems typically, and this was the reason why I started with Mars Lite. You can see the most important difference is that it is working asynchronously and therefore supports arbitrary distances. Okay, and the network is also the problem reliability. You know, there may be interruptions and so on. And there's also one very small problem. It's only a small problem with DRBD with consistency, because if you have any network problem, it just disconnects automatically, and then it resyncs after the connection is stable enough. And during this resync time, the consistency of the mirror is lost, because the blocks are remembered in between in the bitmap, which have changed. And this resync is in a different order than the original requests have arrived, and so you may lose your mirror if you get a final power out or whatever just during this resync. So it's typically only a few seconds. It's a risk for you. Okay. And there's one drawback of Mars. You need some additional space for it, because it internally works like similar to a transactional database. So you need log files, space for log files. And the best is if you use dedicated spindles for performance. I'll show you an example afterwards. Okay, any questions to this slide? Yes?
What's the difference between Mars and Mars Lite?
Okay, Mars is intended to be the full version, released for example, in a year or whatever, 1 year, so you can contribute to it if you like. So this is my first instance of a new system of thinking and of developing software, and hopefully it will not be the last word in this time. Okay. Another question? No.
Does the fact that it is asynchronous mean that it can be used for custom file systems like JetBrains?
You can use it, yes, but on an independent level, because it may take some time until the mirror gets updated. But you always have a consistent images. It may only be outdated, because the log file applying at the secondary side is on the next slide. No, there's only active passive now, but Mars Full may, for example, it may be a feature or a feature request from you that to support active-active. But then it will not run over large distances. That's one of the problems. I just concentrate on this functionality. I try to do that which just cannot be done with the DRBD. This is my first objective now, okay? And these features which are in the section area, currently this is better, yes? This is something we can talk about in 1 year or the like, okay? So now the operating principle. There are two devices. The one is the data here, which is already present. And shared nothing principle, similar to DRBD, means that on the secondary side you have the same data device. And you need space for log files under the /Mars directory. And in between is some black magic, which operates as the memory buffer. And this buffering is essential for performance and for other properties of Mars. The dev Mars MyData device is exactly the same size, so as the underlying log device. So how does it work? This is the operating workflow for write requests. It comes in, and then first it is appended to the log file. And after that, I already can tell the application layer that the write is done. Why? Because the log is containing all write requests, and if, in any case, if the server crashes, I can reconstruct the data out of it. Okay, it's clear. So the log is the primary source of information, and the data device can be updated in background. So this write back is something that's performance critical that can be done when there's no other work to do, for example. Okay. Next point is replication. So here's on the secondary side, and the trick now is to only replicate the log file. Of course, you need an initial thing like DRBD. You have to replicate also the data once. But if you, for example, start with a fresh file system, you need not do that, of course. So the trick is only to replicate the log file and to apply it on the secondary side. And there are two different processes which can be stopped or paused individually. One is the long-distance transfer over the network, and the other one is the log file apply. And they can be switched on or off independently from each other. So for example, you can hold back the secondary copy for 1 hour intentionally to get an old state, for example, as a kind of simple form of backup. Okay, any questions to this slide? Yeah?
What happens if you lose your memory buffer before the longest transfer happens?
With the memory buffer, is it get killed or what?
Lots of things can happen. I mean, you lose a drive, you lose a server, something like this. But basically, your log file, before you can replicate it overall, is it in multiple places locally?
Okay. The trick is the append mode. That means if you don't replicate it, the secondary will be consistent, but have an outdated state. Okay, always. Even if something gets lost from the log file. And I cannot guarantee that the log file will be complete in all at the secondary side. At the primary side, yes, but not at the secondary one. But possibly later it is possible to introduce a synchronous mode where just the application waits until all has been propagated. That's possible, but I don't recommend that because it's a performance killer. So it has a different objective than the RBD. It's not a RAID 1 over network. That's the main difference. Okay, all clear? Yes?
Could you share a little more detail about how the log is implemented? Because you said apparently that it has to be the same size as the...
Not the log. The data device has to be...
Okay, that's fine.
The log file system is just an ordinary file system. You can use X3 or whatever you like. Okay, and the log files have a kind of log rotating similar to MySQL as known.
So is it essentially a ring buffer?
No, it's not a ring buffer, it's append mode. That means you start have an operation called log rotate, and then a new log file is starting, and then you can have a different operation log delete, which deletes old log files which are not needed anymore. Okay?
Okay, so kind of like MySQL replication, pretty much.
Similar to MySQL replication, yes.
What if I have a multi-host environment, such as a Hadoop cluster or something like that? Is this something?
Okay, you can have multiple resources, and you can have mixed operation, and you can replicate to multiple secondaries. And you can switch anyone to anyone. Okay, you can just, on the fly, create another mirror, then it's starting sync and so on. This functional is all available, and I hope that it will scale up to a few hundred custom members. Not yet tested in this very big environments, but there are cases, it's one-on-one, where this should work someday. Okay, so 1 minute for the last slide. No, almost the last slide. Okay, current status. It's a beta, and you can find it on GitHub. This is all you need to remember. Well, one pilot system is already running for 1 year. It was a proof of concept, and it's running on a very loaded server, which collects statistics data from about more than 1,000 other servers. It has a highly random I/O load. And that performs very well, had no problems for 1 year, almost 1 year. And the interface is very similar to DRBD. You just replace the DRBD RDM command by Mars RDM, and the rest is the same, for example, to switch to the primary in this example. Okay, last slide, really last slide, if I have the time, get the time, okay. Performance. Well, do you believe that? It's faster than a raw device. Anyone has objections? It can be faster. There are some preconditions. The load has to be very random, and there have to be very, much writes on it, and you need separate spindles for the /mass directory. Okay? No? Okay, the trick is that the log file has to reside on dedicated spindles. Okay, and the memory buffer is also very important for it, as you can read. Okay, and now why it's faster. I'll go back to 2 slides. Okay, this is append mode. That means sequential I/O on mechanical disks, magnetic disks. Okay, it's clear. So this will be not the bottleneck. Also clear to anyone. So now the trick is to write back in background. It need not only be in background, it can also be in a different order. Why? Because the log applying can be done not only once, you can apply it as 2 times or 3 times as much as you want. It's an idempotent operation to apply the log. It will heal all errors if there are any. Okay? And so this means this write back is in sorted order, just ascending block numbers, sector numbers. And this means the average seek distances on your disk will be smaller. So this means higher throughput, and the total performance is better. Okay, understandable.
Can you skip back to an arbitrary position in the log? So can I go back to a point in time?
Not yet. Under the hood, I have already a mode where the old contents is saved before it is overwritten. This is already implemented under the hood, but not yet visible to users. And later there, I will have a version where you can play back like on a videotape. So it means before image logging and after image logging. Currently, only the after image logging from database technology, you know, is visible to the users, and the other one will appear someday. Okay?
So can you pause if you try to snapshot now?
There are not yet snapshots. Not yet. That means every request is a potential snapshot. You can play back or forward later to any request, individual request, similar to continuous data protection. So the effect is that you can say, go back to stage to this single request with microsecond or nanosecond resolution.
Yeah, but you can't really guarantee that you can only guarantee the consistency at the block level there. You can't
Yes.
really
It must be clear that the consistency is exactly at the block layer level, exactly there.
So for each operation then, sorry.
No problem.
To rewind, do you define the inverse of each operation?
Yes, because the write back here, you can see. Before this write back is started, the old contents is also logged to the log, in this case. So I can revert anything.
Yep.
It's a kind of revert operation.
Doubles.
Yes, it doubles the load, and so it has other drawbacks, it's clear. But if you need the functionality, you can get it. Probably a future version could log it to a different, to a work back log on a separate spindle, then there's no performance problem or the like. This is something I have to elaborate then.
If you actually want to replicate to Mars, how many times larger would your log storage be than the underlying?
That depends on your load and your data, of course.
70%
Okay, the last slide, the example was on a production server having about 50 spindles RAID 6. Okay, and I just misused the spare disks and made a RAID 0 out of them. Okay, just to see the application area of Mars. It's not for home use. Any more questions?
Speaking of consistency, how do you get the consistency of the log file on the remote host?
The consistency of what?
Of the log file on the remote host following the transfer.
The consistency of the network transfer. Okay, I have several things. One is MD5 checksums for each data and the sequence numbers for the block numbers. So these are two checks which are already implemented. And the secondary checks it also. If present, if enabled, you can enable, disable it, and then.
Yeah, first I need to get, the first I guess, abnormally reboot the thing. So it looks out the logs and so on, reading back to the underlying storage. How long does it take to recover the logs so that it's able to be produced again?
In theory, you could even recover from scratch if you keep all the log files forever. In theory. But for testing, I did it already this way. You just need enough space for /mass directory, that's all. Of course, in practice, you cannot do that. Some practical in this pilot system, we had about 50 gigs per day, 50 or 60 gigs. So the problem is not the amount of data, but the randomness of the load. I will talk later about that in my block replication talk. So the randomness is one of the key points for performance, not the sheer amount of data, in most practical cases.
We might have to, we should probably wrap it up there because there's almost certainly pizza on a table out there now for us, which I again have to thank Red Hat for.
But the audience is interested, so
but I mean, if people still want to talk, that's fine too. But it's lunchtime now, so.
Okay, thank you.